In this video, we're going to look at how to include a breadboard into our circuit. A breadboard in real life makes prototyping a lot faster because we can use jumper wires to plug different components together and move things around if we make a mistake. So it's a way to prototype and test ideas out without having to solder or make permanent connections. So we're going to hide the code window here, and on the right hand side we're going to click on Components Basic, and we're going to find the breadboard, which is listed as breadboard small, and drag it onto the screen. I'm just going to put it here on the side so I don't interfere with anything. And actually what I think I'm going to do is delete all of these. So I'm just going to click on them and hit delete really quick. And that way we can start fresh. Okay, so we're going to put our breadboard right above our Arduino. The nice thing about a breadboard, and you can see this in the picture below the video in our lesson, is that the rows are connected to each other and the columns are connected to each other, because underneath this plastic is a piece of metal. These horizontal rows right now are called rails. They allow us to connect all of these holes here on the bottom with a positive voltage and all of these on the next rail with a negative voltage. And then in the actual rows within the breadboard, we can see that they connect vertically. And if you change your orientation, of course you're going to have to use words different than horizontal and vertical, but the premise stays the same. Okay, so on column 9, all these holes are connected together. So let's start by just connecting ground to ground, just to see this idea. So we're going to connect ground to ground, and we're going to change it up here in the top left to black to remind ourselves that that is a black ground wire. So now this entire row will feed down this piece of metal under the plastic, connect to this pin, transfer over the jumper wire back to the Arduino. This will be very helpful because we're going to grab LEDs out of our toolbox next and bring them up here to the top. We don't have to worry about exactly where we place them, but try to leave some space. You can see in mine I've left three little holes in terms of spacing, just to make it a little bit easier to see what we're doing. Next, let's go ahead and connect those grounds up. Remember, on the LED, that's the cathode. So what I can do here is click on the cathode and run it up to this ground. I can click on the cathode, run it to the ground, click on the cathode, run it to the ground. Now, these ground wires that are running up to this negative rail are currently not connected to this negative rail. So what we can do is just make that connection and say ground to ground. Now when electricity attempts to return to the board, or the signal tries to return to the board, when it does pass up the anode of an LED, it'll pass down this cathode leg, through the jumper wire, through the negative rail, through this next jumper wire, and then back down this negative rail to this final jumper wire. So now we've completed one full circuit, half of our circuit. So the last step here is to grab some resistors. We're going to drag those out and we're going to have them bridge the chasm, bridge the gap. And what's going to happen here is we're going to feed the signal from our pins into the leg of the resistor. The resistor will transition over that physical gap, and then the electricity will pass up this row. You can see that when I hover on one of the pinholes, they all connect to each other. So that means everything in this row is currently connected, and it would be the equivalent of sort of soldering all those pieces together. So if we grab some final wires and go from pin 13 up, pin 12 and up, I'll put some space here, and pin 11 and up, you'll see that where I put it in the column or row doesn't matter. So let's just go ahead and color code these really quick for the purposes of discussion. I'm going to go red, orange, and let's say this last one will be, let's go with green. See that the red wire goes from pin 13 right up to the pin right below the resistor. You'll see that pin 12, the orange wire, goes to the very first one, and pin green sort of finds a middle ground. And what's nice here is if I highlight the orange wire's end, I can see that there's a connection under the plastic, and that's shown by these green circles. Same thing with the green. If I highlight the end, I can see it's connected to the resistor. If I highlight the red, I can see it's connected to the resistor. So as the electricity transitions over the resistor to this end, if I highlight this row, I can see it connects to the positive leg. The electricity is going to transition over the LED, down to the cathode leg, back up the jumper wire, and go through the rail. So if I bring up my code, I shouldn't have to change any of it, but just as a reminder, it should go pin 13, pin 12, pin 11. So on my screen, that is left to right. So let's go ahead and start simulation. Make sure it still works like it did in the last video, and look at that. There we go. So we have our lights lighting up in sequence from left to right, and that's all we need.